Global Education Zone, and today we're dealing with mappings. So, but before we start mappings, in the previous video I gave an exercise to you guys, and in the video on the video on source, I gave an exercise to the classwork to you, and I said you should express root 57, root 75 minus 3, root 75 minus 3 over root 3 plus 1. So I asked you guys to express it in the form of a plus b root c, in the form a plus b root c, where a and b are rational numbers. So I will solve that classwork, and you can do your corrections if you missed it. But if you got it, just follow the steps carefully. Now the solution is this. Now the first thing, whenever you see a ratio of two numbers or two group of numbers as such, the first thing you need to do is you have to rationalize the denominator. And so the rationalizing of this denominator involves multiplication of the what they call conjugate. So when you want to rationalize the denominator, you multiply by the conjugate, and the conjugate of this term is formed when you change the plus to minus. So the conjugate of this term is root 3 minus 1. So we multiply up and down. That's the numerator and the denominator. We multiply both by root 3 minus 1. So that will be root 75 minus 3 over root 3 minus plus 1. So multiply up by root 3 minus 1, and we multiply bottom by root 3 minus 1. So basically, now we will have when we multiply this one by root 3 minus 1 up, we have root 75 times 3, that's root 75 times 3. Because you know that in one basic rule of third, you know that when you have two separate surds, they combine into one. So next we have root 75 times minus 1, that's minus root 75. Then we have 3 times minus 3 times root 3, that's minus 3 root 3. Then we have minus 3 times minus 1, that's plus 3. Your minus times minus is 1. So then whenever you rationalize your source, know that this is in the form of, if this is a and this is b, this is a plus b times a minus b. So, and this is difference of two squares, and it's called a square minus b square. So that means root 3 square minus 1 square. So in the numerator we have root 75. So we have it as root 25 times 3, because 25 times 3 will give us 75. So it's still the same thing as root 25 times 3 then minus next we have root minus root 75, that's minus root 25 times 3, that's minus 3 root 3, then plus 3 over. So in the denominator we have root 3 squared. Saying, you know, in the last video I mentioned earlier that root always cancels square. That means we have 3 remaining. Then minus 1 square is still 1. That's so here we have root 25. When we open the square, we have 5 times then root 9. This becomes 9, and then root 9 is what, 3. 5 times 3 over that's 15 minus this 5 root 3, and this is minus 3 root 3 plus 3 over 2. And this becomes 15 minus 5 root 3 minus 3 root 3, that's minus 8 root 3, because these are similar sorts. So anytime you have any sort where you have a number as a product of the same sort, you can add and subtract them because they are similar sorts. That's plus 3 over 2. That becomes 15 plus 3, that's 18 minus 8 root 3 over 2. So that becomes what? Now you can say 18 divided by 2, that's 9 minus 8 divided by 2, that's 4 root 3. So our answer is 9 minus 4 root 3. So now our A is 9, yeah, and then our B is minus 4. So that's the solution of the question. So this is the correction of the exercise I gave you guys in the last video. So today let's move on to today's work. So today's work we are dealing with mappings, right? So for mappings we will deal with one-on-one and auto mappings first. So what's a mapping first? A mapping is basically, so yeah, I'm back. So basically a mapping is basically a rule, any rule that assigns a number another number, or that assigns an object another object. So and that first object is called the basic object, and then the object assigned to it is called the image. So and that image is like a set of objects where you have your objects are assigned. So and where those objects that are assigned are called the range. So basically, let me explain this in the diagram so you can understand better. Now, if you have something like this is a circle and you have some numbers, you have let's say you have some letters A, B, C, D. Then you have another circle, and then this second circle you have just like when you are conducting a marriage, you have 4 couples. Then you have the bridegrooms, and then you have the brides. Then the brides are E, F, GH. Now the bride of A is E, the bride of C is G. Now in this example, the bride of A is E, right? Now this A is called the domain. Why this E is called, this circle A is called the domain. Why this circle this second circle is called the codomain. And this one is called it's kind of like the basic element. And this E, this bride, is called the image. So basically we have a domain, we have a codomain, then we have a range. So the ones that are wedded already is called the range. In the codomains, those brides are already wedded, they are called the range. So basically this is just my own way of explaining mappings so that you can understand basically. So the subset of the codomain. Now this is the domain. This is the codomain. So the subset of the codomain that are images of the codomain, they are called the range. So the range here is the set of, so this is set notation, set E, F. So those are the married parts of the codomain. So basically you can use that to understand and understand it better. So now there are different types of mapping. Let's talk about one-on-one mapping. So that one-on-one mapping is that each of these elements, forget about the example about marriage earlier, let's continue the mapping in further mass context. Now this, in one-on-one mapping, each of these elements has its own image. So each one has its own unique image. So different elements in the domain have their own different images in the codomain. So that's what's called in one-on-one mapping. So now next we'll talk about onto mapping. And onto mapping is a mapping whereby every of the elements of the codomain have a corresponding element in the domain. So basically that is called an onto mapping. So one-on-one mapping and onto mapping, there are two basic types of mapping you need to understand. There are other types of mapping too. So but let me give you an exercise. So we have to determine if this mapping, let me give you an exercise. Let's check if this mapping X, Y, Z and this, so between this and this we have this, we have this, we have this, we have this, sorry, we have this, we have this, we have this. Now we asked whether this is a one-on-one or an onto mapping. So we asked whether it's a one-on-one or an onto mapping, right? Now let's decide that. Basically one-on-one mapping. So yes, basically this particular one is an onto mapping because each of the elements in the codomain has a element in the domain, so it's an onto mapping. But it's not a one-on-one mapping because each of these elements, they don't have difference. So this one has two. So and even if we have something like this, something like let's assume we have two, one of them, this one, and then this one is also mapped here. This one is mapped here. Then let's say we have let's say there are XYZ, P. We have this one mapped here. So this one becomes an onto mapping because each of the elements of the codomain has a corresponding element in the domain. But it is not a one-on-one mapping because this both X and Y are mapped to the same image in the codomain. So it's not a one-on-one. So a one-on-one mapping is the one where each of the elements in the domain has a distinct and different element. So this one, if X and Y share the same image, then it's not a one-on-one mapping. So that's how you know the difference between one-on-one and onto mapping. So next, there are different representation of mapping. So you have this representation. You can represent it as arrow diagrams. Now these are called arrow diagrams. Then we can also represent them as parallel axes. So if I wanted to represent this as a parallel axis, I'll have an axis of the domain and have an axis for the codomain. Then basically I would have the domain is the range, is always above this domain, and this is the range. So that range is like the part of the codomain that have been mapped to the domain. So basically that range, every element in the range must be mapped to the codomain. So now we have in our domain we have A, B, C, D. I'm representing this as a parallel axis. Now this A has been mapped to E. Imagine we have E, then we have F, we have G, we have H. So this E has been mapped to E, this B has been mapped to F, this C has been mapped to G, and then this D has been mapped to H. So this mapping is both a one-on-one and an onto mapping. It's a one-on-one mapping because each of the elements in the domain has a distinct and unique image in the code in the range or codomain. This specifically a range. Then it's also an onto mapping because each of these in the range has been mapped to something else. Each of these has been mapped to something. So basically, that's when you have every element of the codomain mapped. It's called an onto mapping. So next, we'll talk about special types of mapping. We have special mappings. We have identity mapping. And identity mapping is when each of the elements in the domain has been mapped to a single element in the codomain. So that means in something like identity mapping, it has its own elements and it has been mapped to itself. So basically, if we have something like this, if we have a domain of A, B, and C, and then we have a codomain of B, C, and A, and then if element A is in the codomain is mapped to A in the codomain, and B is in the domain is mapped to B in the codomain, and then C again in the domain is mapped to C in the codomain, that is called an identity mapping because each element maps onto itself. Then we also have constant mapping. That means when each element maps to a single element. So basically, well, if each of A, B, and C maps onto A, if A maps to A, B maps to A again, and C maps to A, so each of them, all of them map to the same element in the codomain is called an constant mapping. So other types of mapping include composite mappings, and for examples in this video, we'll be dealing mostly with composite mappings. And composite mappings is when you have a codomain, and that codomain is the domain of another codomain. So basically, let me explain myself. So when you're talking about you have a, assume this is your normal domain, then you have A, B, C. Then the codomain of this is D, E, F. Then you have another one, G, H, I. Now this domain has a codomain, and we have elements mapped, right? Now for this codomain is also the domain of this and this other one. So it's just like this is mapped to something, and then something is mapped to this other one. So it's called a composite mapping. So and then we'll be dealing with these composite mappings. Let me give an example. Then we have what we call functions. We represent these arrows as functions. So this one is called a function, and when the arrow goes in this direction, the destination of the arrow is the function of the initial arrow. So if you have A, then the destination of that arrow D will be equal to the function of A, the function of A. So a mapping basically is a function. It's just a function that maps other elements with an element. So it's like the function of A is equal to D. So now we have different type of functions. Let's call our functions like F. We will have a function of F, and then we have F of A. The function of A is what? Is 2A plus 6. So that's the formula. Now this kind of functions is under mappings, and this kind of mappings are called functions, because functions, there are specific types of mapping that involve numbers. So in this type of mappings, you have 2A plus 6. 6 is a number, 2 is a number. So a mapping whose codomain consists of only numbers is called a function. So then we'll change all these letters into numbers soon. But let's work with this. Then if we have another mapping, let's make a composite mapping now. But before that, let's look at what is called an inverse mapping. An inverse mapping is like mapping in the opposite direction. So if the function of A is B, then B is 2A plus 6. So and this if you have to find the inverse function of A. So first of all, the first thing you do is make A your subject. So basically you have this equation here. You put 6 to the other side. That will be minus 6 is equal to 2. Then now you divide both sides by 2. When you divide both sides by 2, you have 2 will cancel the 2. You have A as a subject remaining. So that means A is B minus 6 over 2, right? That means you have this A is equal to B minus 6 over 2. It's called the inverse function of B. So F minus 1 of B. This is the inverse function of B. Now this inverse function of B, when you substitute B and you turn to A, when you substitute the B and you turn to A, it's called an inverse function of A. So now instead of writing inverse function of B, we change the B to A. That means we write A minus 6 over 2. that will be the inverse function of A. So this is how you calculate the inverse function of the mapping. So basically, after inverse function, let's deal with composite mappings. So now if you want to represent a composite mapping or a composite function, you will be mapping a function on another function. So let me give an example. An example of this is if f, now let's change to x, which is the normal letter for most of questions like this. If function of x is 2a plus 6, and then g of x, assume this is a composite mapping now, and then we have numbers instead. We have a function of x. Now this is called the function of x, and then this is called the g of x, and then this is called x. So this is the domain of x, this is the codomain, and this is the domain of the codomain. Sorry, this is the codomain of the codomain of x. So that's kind of like a composite mapping. So now we will change the letters and turn it to numbers. Now if we have something like this, when we have domains of 1, 2, and 3, then our function of x, if x is 1, our function what? That's function of 1. That what? 2 times, let's turn it to x. 2 times x, that's 2 times 1 plus 6. That's 2 times 1 is 2, that's 2. 2 plus 6, that's 8. So our 1 will map to 8 in this codomain. So that will be that will be the image of the element. Now then we have 2. If we have 2 here, our 2 will map to, when we change substitute 2, we have 2 times 2, that's 4. 4 plus 6, that's 10. So we map, this will map to 10. Then when we have 3 will map to what? 3 map to 3. That will 2 times 3, that's 6. 6 plus 6, that's 12. So we have 12. So basically we are mapping everything to the image. Now if this f of x will map it onto another one again. Now what will our images be? So now this is a typical further math question. And this g of x, if we have the equation of g of x as x squared minus 10. Now basically let's work on this. Now if we have, they said find the function of g of 2. Now how do you calculate this? How do you find this question? You have to find the function of this. Now you have the function of g of 2. Now in this kind of question, the first thing you do is you look for what is in the bracket. So that means the first thing you are going to do, you are going to look for g of 2. G of 2 is what? G of 2 is x squared, that's 2 squared minus 10. 2 squared is 2 times, so that's 4. 4 minus 10, that's minus 6. So that means you are looking for the function of g of 2, and now you've gotten g of 2 as minus 6, right? So that means indirectly you are looking for the function of minus 6. So that means we are going to substitute that into our equation. That's function of minus 6. So substituting minus 6 into our equation, we have function of minus 6 is 2 of minus 6 times minus 6 plus 6. That's what? 2 times minus 6 plus 6. That's 2. That's 2 times minus 6 minus 12 plus 6. That's minus 6. That's our answer here. So our answer is minus 6. So basically, if you are to solve questions like this is how you solve it. The first thing you do is you look for the one that is closest to the number, then you look for the one covering that. That's the one that comes first. You don't do the one that comes first. Do the one that comes last first. So since g of x, the function that comes last is what you do. So this g of x comes last. So you do it before you now substitute into it and then use the function of x to calculate it. So then this is as far as we can go, and then before this video ends, I will give a classwork which I will answer in the next video. And then this classwork will be on, I will ask you to find the function of if the function of a is given as 2 minus 3a, and the g of a is given as 8 a plus 1. Then now we find the inverse function of a, then find the inverse function of g, find the g inverse of a, find the f inverse of a. Then number 3, find the function of the g of 2. So when you have something like 2. So these are the questions you'll be asked to solve. So, and I'm giving this as a class work. So if for those of you watching this video, when you get to this place, please solve it, and then I'll do the correction in the next video. Thank you for watching.